So these are the recordings of me jumping 1 through 5 and then putting the tape behind my heel to mark the measurement. On the right, you'll see my starting point. I always started behind that, and then I put the tape behind my heel because it would give me more accurate numbers. And they're all relatively in the same area, like less than a meter. I mean, jump 3 is exactly a meter, which I think was pretty cool. But then, I kept putting it behind my heel so I could measure it. So in order to do the rest of the lab with the jumping and everything, I had to figure out my weight in newtons, which I did by multiplying it by 4.5. And then I multiplied that by all of the gravitational constants compared to Earth to get my calculated weight in newtons on all of the planets and the moon. So I did that before I did anything else. So part B was actually at the beginning, well, part of it was me jumping, and I got the average of those jumps, which is 94 centimeters or 0.94 meters. And then I divided 0.94 many times, divided by all the gravitational constants compared to Earth to get my calculated jump on the moon, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune to see how far I would jump based on my weight on all of those other planets and the moon, because weight is in relation to gravity, because you would weigh different weights on different planets, as you could see up above in the newtons. So having my weight and then having me do the actual trials here on Earth would give me a great basis for seeing how I could do on the other planets, and those are estimates, of course, because I can't actually go jump on all those other planets. But yeah, that's the calculations for how I would jump on all the other planets and the moon. Someone would weigh more on Mercury than the moon because the gravitational constant compared to Earth is higher on Mercury than it is the moon, and gravitational force means more weight. A person could jump further on the moon because of this than Jupiter, because these would jump further on a planet with less of a gravitational constant compared to Earth, so you jump further, and mass and distance affect the gravity between two objects, and mass is not the same as weight, because mass has to do with matter, and you can only really change mass if you eat something or you're pregnant, but you can't change mass the way you would change weight, because it's a lot different, and mass has to do with matter and weight has to do with gravity, so your mass wouldn't change on other planets.